Welcome back, everyone. First of all, before I forget what I did in the morning, we will also use for this keynote Slido. So you can use Slido for asking your questions by going to slide.do and put in the hashtag OOP Digital. And another thing is for this keynote, because it's in English, you can also make use of the live transcript and activate the subtitles. So that is a possibility to keep following on. So our next keynote speaker has been influencing software and architecture development for, you won't bet that, for as long as OOP exists. And that is for 30 years. Therefore, I wouldn't be surprised if most of you know him already. For example, he's the originator of behavior-driven development and deliberate discovery. And, you know, if you don't know what these are, you really should check it out. And what I particularly like about him is that despite all these years, you can tell he keeps having fun doing what he's doing. That's what I really super like about you, Daniel. So it is my great pleasure to welcome Daniel Terhorst-North. Yours is the screen.
Fantastic, thank you. And hello, everybody. Good afternoon. I'm so sorry we're not doing this in person. I came to OOP quite a lot of years ago and had just such a brilliant time. This is the next best thing. We're doing this virtually. I hope the virtual lunch was fantastic and you're enjoying a good virtual coffee. So I want to talk about an acronym. I want to talk about an acronym called CUPID. And I guess really this is a culmination of a whole load of thinking about what I care about in software. And as with many things I've done over the years, this wasn't my fault. Okay, so this was kind of motivated by some other folks. I'll explain as we go. So firstly, some backstory. A few years ago, 2017, I gave a 5-minute lightning talk about Solid. And the reason I gave a 5-minute lightning talk about Solid is, for a start, I was invited to give a 5-minute lightning talk at a fun after-party conference called PubConf that takes place in a pub. And the purpose of this mini conference is to have some fun, to give a series of these 5-minute talks, and the talks are scored and points awarded by how loudly a load of drunk people cheer in a pub. And so it's an Ignite style, so auto advancing slides, 20 slides, 5 minutes, 15 seconds per slide. And I'm lazy. And I thought, well, I'm going to give a talk about Solid, because then basically the talk structures itself. There are, for those of you who don't know, so Solid is an acronym based on a number of object-oriented design principles that were first kind of articulated by Robert C. Martin, and then a chap called Mike Feathers noticed that if you took the first 5 of these 100 or so principles, the first letters, and changed the order a bit, then you got this word solid, and so they became known as the solid principles. I don't have time to go into what all 5 of them are in detail. But very briefly, single responsibility, open close principle, Liskov substitutability, interface segregation, and dependency inversion. So there's a bit of Googling / Wikipedia homework for you. And my issue with the solid principles is really that they're kind of an age. They're of an era. And so they're largely anachronistic now. So I describe them as neither necessary nor sufficient for writing good software. And that upsets some people. So I thought, okay, I'll have some fun with this. And I put a talk together. And essentially I did 3 slides. 1 slide to say what the letter meant, what the acronym was. 1 slide to explain why I didn't think it made sense anymore. And another slide to what I thought was going to be to propose an alternative. And what I found as I was writing this talk is that the alternative always ended up as the same thing, which is write simple code. And that then leaves you the obvious challenge of, what does simple mean? So anyway, so I put this talk together, and it was fun, and it went across very well, and there was much cheering. And then I put the slides online, and then a bunch of folks who called themselves software craftsmen got really cross with the fact that I was critiquing Solid. So that's the kind of the backstory of me really kind of deconstructing Solid, if you like, unpacking Solid. And then sometime later, almost exactly a year ago, in fact, February last year, there's a brilliant meetup in London called the Extreme Tuesday Club. It's been going for decades. I think it's one of the oldest agile meetups in the world. It's now online. It's virtual. And they were having an Extreme Tuesday Club about Solid. And one of the organizers said, hey, you did that thing a couple of years ago about Solid. Do you want to come along and talk about it at our meetup? And I said, yes, that'd be great fun. And then he gave me a brilliant challenge. He said, okay, so you're clearly not a massive fan of Solid. What would you replace it with? So those 5 principles don't work for you. What would you replace them with? And that kind of that leaves the question, like, can you replace them with anything? Are there 5? Are there universal properties of software, universal principles that you can apply to software? Is that even an answerable question? And so I went off and thought about this, and I came back with an acronym, my own acronym, and my acronym is CUPID. And so for non-native English speakers, Cupid is the Roman god of love, of romantic love. And so it was February, it was near Valentine's Day, and I thought Cupid, partly because I wanted something that was so obviously in contrast to Solid, with its machismo, bro grammar kind of culture around software craftsmanship. And so Cupid is kind of fluffy and lovely and romantic and joyful. And so that's what I did. I came up with what's called a backronym. So I started with the letters and then fitted some things to the letters. And then and it went across really well, and I got some really positive feedback. And it wasn't just all kind of flippant and not serious. I did some serious thinking about it, and it's one of those situations where where you're given a constraint in which to present an idea. And so that was the constraint, was can you constrain these things to a 5-letter acronym? And so then shortly after that, I had someone who'd been at that conference, had been at the meetup, said, look, we're having a conference and it'd be great if you could talk about Cupid. And now that put me on the hook. Now I had to actually write something down about Cupid. So I did. And that's where we ended up. So this talk I've given this talk a number of times now. As I say, this idea is about a year old. And I largely give a very similar talk each time. I often, with my talks, I go off on totally different tangents. With this talk, I'm really trying to get an idea across, or a set of principles across, that are really important to me. And also, it's really exciting because as time goes on, you start to get feedback. And so now I'm hearing from people applying these CUPID ideas in things like a code review. So someone on Twitter has been talking to me about how they've got a bit of downtime at the end of last year, and they're doing a full-scale review of their entire kind of software estate, and they're using CUPID to do it. And this is really exciting. So without further ado, let's take a look at this. Who are we writing software for? Right, when we're writing code, who are we writing code for? Back in, early 2000s, I came across, probably late 90s, in fact, I came across Martin Fowler's wonderful book, Refactoring. And we don't even think about refactoring as a thing anymore. It's just built into our tools. It's built into our IDEs. It's automated shortcuts. So back in the 90s, it was being invented. We were thinking about extracting interfaces, renaming methods. All of this stuff was new. That I know folks who've been programming for less than, 15 years, 20 years, are going to find it really odd that we didn't really used to rename code. If we as our understanding of a system, of a software system, evolves, and we realize that things should have different names, we weren't really doing that. We just kind of lived with the name we had, and then it was tacit knowledge. You had to know that the customer class was really an account holder, and there's loads of different kinds of customers. But when you see that particular customer class in that package, it means an account holder. And you just had to know the secrets. And eventually, you had to learn all the secrets, and that's how you wrote software. And Ward Cunningham famously was writing a system, and the system presented some information on the screen. And he said, what we're going to do is we're not going to have any intermediate layer. We're just going to take the names of the fields and display them on the screen as the field names. And someone in his team said, yeah, but our users like to change the names of these fields all the time. What are we going to do? And he said, well, we're just going to have to get really good at renaming fields, right? We have to get really good at renaming properties in classes. And it was this kind of mindset that led to refactoring. It said, let's keep the code as close as possible to the user. And that means that as the user's mind changes, or as our understanding of the world changes, we need to morph the code. So at the beginning of this book, Martin writes these wonderful words, and these words really landed for me. Any fool can write code that a computer can understand. I'm that fool. I was 10 years into a career being that fool. Good programmers write code that humans can understand. And I had a real epiphany moment. And then, so we're looking at this word understand. Can we do better than understand, though? And then sometime later, I came across some wonderful short articles by Dick Gabriel, who's one of the kind of forefathers of Lisp and, well, I guess, modern programming. And he wrote a whole series of wonderful essays. And in one of them, he talks about habitability. So the essay is called Habitability and Piecemeal Growth, and the set of essays is called Patterns in Software. And just look it up, it's wonderful. And he says this, he says, habitability is the characteristic of source code that enables, and then he says a whole bunch of different types of people, to understand its construction and intentions and to change it comfortably and confidently. Habitability makes a place livable, like home. Wow, that's, yeah, habitable. You live in code, right? As a programmer, you live in code. And I thought, well, habitable, that sounds better. So what about joyful? What if instead of, code that's okay to live in or understandable, what about code that genuinely makes you happy to be working on it? What about joyful code? So think about a code base that is joyful to work with. Think about a situation in your life where you've worked on code and you enjoyed working with that code. It's not your code, right? It's someone else's code, and it just makes you happy to work with it. Can we describe what makes it joyful? Are there characteristics of code, universal characteristics of code that are joyful? And what kind of properties does code have? And the word properties is very deliberate in that question. And this is why I'm talking about properties rather than principles. So principles are rules. Okay, principles are rules or guidelines, and they define boundaries. So you're following the rules or you're not following the rules. You're conforming to the principle or you're wrong. And I find this quite sort of binary and exclusive. And instead, if you think of properties, they're qualities. And so your code can have more of that quality or less of that quality. So you can think of it like a center. So and you can move that code towards that center. You can give this code more of that property or further away from it, but it never has none. It's never excluded. There's never a point where it's beyond any kind of redemption. And so at the risk of getting a bit meta, I want to look at properties for properties. What does that mean? Well, let's think about what kind of properties would be useful to describe software. So the first thing I want my properties to be is practical. I want them to be easy to articulate. I want them to be easy to assess and easy to adopt. What does that mean? They're easy to describe. Okay, I'm a native English speaker speaking to a largely German audience. I should be able, in simple, straightforward language, to describe each of these properties in such a way that they make sense to you. Easy to assess. Once you understand these properties, once you've heard about these properties, it should be easy for you to overlay them on your code and assess your code against these properties. If it's hard, if it's complex, if it's obtuse, then it's, well, you're not going to for a start, but also you're not going to know whether it's going well, right? And easy to adopt. This is not an all or nothing. This is not a big bang. The idea with each of these properties is you can choose a property, you can choose a piece of code, and you can say, right, how could we make this code more that? How could we make this code more X, move it towards Y? So what I want is a very easy on-ramp. I want it to be very easy for you to try these things out. The second property for properties is that they're human. So when I'm describing joyful code, I'm describing it from the perspective of human beings, okay, not from the perspective of code. I'll explain that as we go. But certainly a lot of the solid principles and general software kind of guidance is kind of abstract and cold and doesn't really take the fact that there's human beings interacting with that code into account, which is why I was so blown away by Martin Fowler's quote and so blown away by Dick Gabriel's whole essay on habitability, is they're putting the human beings at the center of software development. I think that's really important. And the third characteristic, the third property I wanted is that these properties should not be trivial. I want them to be layered. So yes, for beginners, I can describe them quickly. I can describe them easily. But then as you're a more experienced developer, more experienced programmer, we can start to unpack more of the nuance and more of the layers of meaning behind these things. So without any further ado, here's the reveal. So CUPID is 5 properties or characteristics of code. The first is that code is composable, so it should play well with others. The second is that it follows the Unix philosophy of doing one thing well. So code that does one thing well. The next thing is that code is predictable. So code does what you expect. It does what you think it should do. The next I is idiomatic. So it feels natural. It feels obvious to someone who is familiar with that technology. And the final thing is that it's domain-based. And domain-based isn't just about domain-driven design and the language you use. There's more to it than that. So I want to spend kind of the rest of the talk, if you like, unpacking each of these or exploring each of these 5 characteristics. I will say, and this is one of the fun things about coming up with a backronym, there were a number of candidates for each letter. And I, in particular, had lots of candidates and that didn't make the cut. And I suspect there's another series of talks where I go into some of the shortlists. But what I found with these 5 properties, these 5 characteristics, is that they seem to, 2 things happen. One is they reinforce each other. So composable code tends to do one thing well. Idiomatic code tends to be predictable, and so on, right? So as you're moving, you know, these, it's not often with these properties that I'm finding that I have to make trade-offs to make it more predictable. I have to make it less idiomatic, say. They tend to all be kind of driving in the same direction. And also, as I look at a lot of the shortlist items, they seem to be derivative of these. So in other words, these seem to be the kind of the core, the base, if you like, the foundational properties. And the other properties that I explored or that I considered are a direct consequence of following these. So I'm quite pleased with how this has come out. So let's take a look at composable then. What does that mean? Code that's easy to use gets used and used and used again. And if it's easy for me to pick up some code, if it's easy to me to make sense of code, then I'm more likely to use it. So composable code should have a small surface area. I'm a big fan of the idea of power to weight. So what I want is a small API, a small interface that does a lot for me. I can take small pieces and I can compose them and I can make really sophisticated code. I can solve hard problems using very simple pieces much more than I can solve problems using very complicated pieces. A small surface area has less to learn, so it's easier for me to figure out whether it's what I need. It has less to go wrong, so I'm more likely to trust it. And it has less to conflict. It's less likely that a component I'm using is going to have some kind of version conflict or data structure conflict or any other kind of conflict with other code. I'm a big fan of intention revealing names in things. So intention revealing in a composability sense means it's easy to find this code, right? If I go looking for something that solves a problem, the language I use to describe that problem, I should be able to just find code that solves that problem. Right? Searchability, discoverability is a really big deal. So code that has really intention revealing name and purpose is easy to discover. It's also easy to evaluate, and really, I guess it's easy to disqualify. It's easy to see whether this is not the thing I want. And honestly, I would much rather look at many things and very quickly discover that each one of them is not the thing I want than to get a long way down the path with a single thing and then find out that it's not going to solve my problem later on. So if it's easy for me to evaluate, it's easy for me to figure out whether this will solve my problem, I'm then on my way again. And the third element of composability is that it has minimal dependencies. So there's a wonderful quote by the late Joe Armstrong, who invented Erlang, a brilliant programmer. And he's talking about object-oriented programming in particular, and object-oriented languages. He says, you wanted a banana, but you got the whole gorilla. You know, you got the whole jungle. And so the very first open source code I ever wrote, which was back in 2003, I think, the internet tells me, was a testing tool, or a tool for doing TDD rather, with enterprise Java beans. If you don't know what enterprise Java beans are, you are very lucky. If you do know what enterprise Java beans are, you may recall how incredibly hard they are to test, because they need a huge amount of infrastructure and plumbing around them before you can do anything useful with them. So I wrote this thing XJB, which was about testing EJBs. And it had some logging in it, and it used log4j, and I made it open source. And a colleague of mine said, oh, yeah, I can't use it. What do you mean? Well, you're using log4j. And I'm thinking, like, you know, everyone's using log4j, right? It's the single, so, you know, it's the single most obvious. At that point, it was a single practical Java logging framework. He said, yes, but you're using this version of it, and my project's using this other version of it. And that means that I can't use your testing thing, your TDD tool. And I was thinking, wow, that's a really dumb reason to not be able to use a tool. Why don't I take all the logging out? And so what I did is I abstracted all the logging away. And if you didn't plug something in, then it would just not log. And if you did plug something in, it would use that. And that single decision meant that lots more people now had access to this thing, because what I'd written was not a logging tool or a tool that even needed logging. It was a tool that enabled you to do TDD. So stripping away dependencies. And I've done a 180 on this. I very much used to, like, you know, if there's a library out there, if there's an API out there, go get it. Whereas now I've gone exactly the opposite way. Like any dependency, any new library coming in really has to be worth it. So I tend to push back on any new dependencies. I'd much rather write a few lines of code than pull in a huge library that has a few lines of code in it. So that's composable. What's next? Unix philosophy. So Unix has been around for like ever. It's been around, well, it's actually been around for as long as I've been around. So it was 1969 it was invented, and 1969 I was invented. So we're both in our 50s. Unix is everywhere. Unix is in your phone, it's in your computer, it's in the cloud, it runs the cloud. How did it become so insanely popular? I think it became so insanely popular because the model it has is very, very simple. In Unix, everything's a file. The file system's a file. Files are files, directories are files, network devices are files, memories files, processes are files, everything's files. And that means that you have a very simple programming model. It also has this model of make each program do one thing well and do only one thing. So for instance, ls lists files, okay, and it lists files in any way you could possibly imagine, right? But here's the thing, ls doesn't know anything about files. ls talks to something else, and something else is called stat. And stat knows all about files, but what stat does is it gives you back just a structured record with a bunch of information in. What ls does is it takes the structured records that come back from stat and formats them. So ls isn't actually a file lister. It's a stat output formatter, right? And so these things that do one very opinionated thing very comprehensively work really well together. And doing one thing well, along with composability, there's practically nothing you can't do. So a kind of a sub-bullet, if you like, of the do one thing well is to expect the output of every program to become the input to another. If you can hear my dog yapping in the background, speaking at virtual events is a lot like being on stage with your yappy dog. So expect the output of every program to become the input to another. So for instance, we could take cat, which gives me the contents of a file, grep, which filters that content, sed, which then transforms it, sort, which takes all those results and sorts them as a list, and unique, which removes any duplicates, and so on and so on and so on. So each of those commands does its one thing really well. But isn't that the same as single responsibility principle? I hear you ask, because usually people ask that. Not really. So again, SRP is about how code changes. Like the canonical definition of SRP is that code should have one and only one reason to change. And the examples are things like a widget in a screen. So the content of the widget, the business rules, the behavior of the data, if you like, inside that widget should be different from any of the code that displays it, and you have them in separate places. And yeah, I mean, that's one division. That makes sense. You might want to do that, but you don't have to. And it may be a premature structural optimization. It may be that those pieces of code are changing together. Okay. And so, and now I'm going to have to change the business logic here. And this goes back to the days of J2EE, Enterprise Java, where most code was just about getting and setting values and passing them along a chain of dependencies, none of which needed to be there. When Rails came along and collapsed the whole thing into get values out of a database, put them on a screen, was hailed as revolutionary, even though, Ward Cunningham and his gang had been doing this in the 90s in Smalltalk. This is how these things change. So SRP is about how code changes. Unix philosophy is about what the code does. It's from a consumer perspective. So as a consumer of that code, what does it do? Not how does the code change? Okay, next principle. Predictable. I want code to be predictable. Predictable code is joyful. What does predictable mean? Predictable is a huge, huge topic. In fact, each of these is a pretty big topic. And my plan is to do follow-up work to dive into each of these properties as we go on. So this is the whistle-stop tour. So, okay, predictable is this. It behaves as expected. It does what you think it does. When you read the code, when you look at the code, when you run the code, it does what you think it will do. Kent Beck has his rules of good programming. He says, rule 1, passes all the tests, right? Does it work? Does it do what it's supposed to do? So I think of predictability as a generalization of tested, if you like. So it behaves as you expect, even when there's no tests. And certainly early in my career, and I wrote a lot of C and a lot of C++ in the 90s. And there wasn't a culture of TDD, and there wasn't a culture of automated testing in any sense. That came much later. And yet I remember working on large, complex code bases, doing really quite sophisticated things like image processing, digital image processing, producing telecoms billing systems, non-trivial software that were really, really fun to work with, easy to navigate, not intimidating because of the way they were written, because of the way they were structured. And they behaved as expected. Each module did what it was supposed to do. The next thing about predictability is determinism. So the behavior is one element, but then let's look at what it does when it's running. So, does it have massive spikes in memory? Does it suddenly chew up all the CPU or GPU or processing power that it can? Does it swamp the network? Does it do these things unpredictably? Does it do these things randomly? Does it operate differently in different environments and so on? So predictable is about determinism as well. I want to know how it runs as well as what it does. And the third part of this is about observability, and I'm using observability in the technical sense, if you like, of control theory. So I should be able to. So observability is the degree to which I can infer the internal state of a system from its outputs. So another way to think of it is linearity. So if I can look at a system's outputs and just from its outputs I can know everything about its health, then that means the system is observable. by and large, we tend to bolt observability on the end as a kind of, and we call it monitoring and things like that. Observability of a system is a characteristic you need to build in from the get-go. So this is about instrumentation. This is about designing systems that can tell you what they're doing and that can emit that. So telemetry, which is the ability to emit information about yourself. So in instrumentation and telemetry are non-trivial to add after the fact. We need to bake those into our systems. And once we have an observable system that's deterministic in terms of behavioral characteristics and operating characteristics, and the code does what I think it's going to do, that code is a joy to work with. We get to that habitability again. I have confidence and I have comfort. I'm confident to make changes and I'm comfortable that they're going to work. So the I in CUPID then is we're looking at idiomatic code. Now, again, this is a huge topic. So I'm using idiomatic in the sense that someone who has experience in that technology, someone who has experience in that language, will look at that code and it will seem familiar. So that's the acid test. And and in particular, I find myself doing this. This is like advice to me that I'm just sharing with you. When I'm learning a new technology, I know that I'm writing it in the style of technologies I know. So when I first started learning Python, I was writing Java in Python because I know Java. And so all of my Python had objects and classes and all kinds of things all over the place, which is fine. You know, Python supports OO as a first class thing, although it has various different variants of it. But then as I understood more about Python, I realized that Python, idiomatic Python, it doesn't tend to use objects and classes in the same way as class-based OO languages. And the reason for that is it's got really good ways of doing these things. So functions can just live. A function doesn't have to have a home. Any code, any source file is its own module, okay, named after the source file. So the fact that code is in a source file to start with means it's already namespaced. It's in a namespace, which is the module that you're in. So you don't need to use classes and objects as namespacing. For most things, you only need one other thing. And so you don't even need classes and objects in the first place. Each module is its own singleton. And there are much lighter weight tools at your disposal than objects if you want to have a whole bunch of different sets of a value, sets of a structured value. You've got dictionaries and tuples and named tuples and a whole bunch of very lightweight tools, language constructs that mean you don't need to reach for OO. Anyway, the short version of this is some weeks or months or whatever later, I went back and revisited some code, and most of the code just went ka-chink, 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 and there was hardly any code left. And the code that was left did what I wanted the thing to do. And all the other code was Java me projecting onto future Python me. And so when you're looking at a new language, it's about giving yourself time to learn the language. It may look familiar to you, but you are someone who doesn't know that language yet. So idiomatic code is code that looks familiar to someone who is already experienced in that language, which will be future you. So let's be kind to future you. So what does that mean? It means you use standard language features and constructs. You use standard libraries. Where there are multiple choices of things, use the one that everyone uses. Frameworks and tool chain. Some languages and some tool stacks, if you like, are much more opinionated than others. So JavaScript and Node.js is notoriously unopinionated. There are like 100 different Node modules that do practically anything. And that means then that it's much harder to figure out what idiomatic JavaScript looks like. There's no such thing. What you have instead is local idioms. Is the choices that the programmers who worked on the code before you or the people in your team, the choices you are going to make. And this is about having a house style. This is about having coding design standards. They may exist, they may not, they may be de facto, they may be what's already there. But you want to align these with the project itself, with the dependencies of the project, with the various platforms that you're interacting with in the organization and across the organization. And as these things broaden out, you may need to create them yourself. And one of the most unsettling things I find looking at an unfamiliar code base is where every time you look at a different bit of code, it was clearly written by a different person at a different point in time. You had different opinions about how code should look. And so the cognitive load of just making sense of this code is really high. It hurts to try and process the code, let alone figure out what it's doing. So, and the takeaway, I guess, the advice is this: you can't write idiomatic code unless you take the time to learn the idioms. So it's on me as a programmer. I'm learning Rust at the moment. I'm finding it's a fascinating language. It's frustrating and brilliant in equal measure. I'm trying to write idiomatic Rust. Of course, my Rust is rubbish at the moment, so I keep going back over code I've already written and finding better ways to do it. So I take the time to learn the idioms, and then I can start to reason about Rust code. And then finally, the D of CUPID, your code should be domain-based. Domain-based code is a joy to use. More domain-based code is better. So this isn't just about using domain language. So there's a lovely anthology or compilation book by Kevlin Henney, 97 Things Every Programmer Should Know. The one thing that I contributed to that is the idea of coding in the language of the domain. So use domain terms, use domain language when you're writing code. And be aware, of course, there's multiple domains. When you start getting into domain-driven design, you get what used to be called strategic domain-driven design, and is really about how organizations work. So you're going to have bounded contexts. Within bounded contexts, certain words will have certain meanings. You go to a different context, and the same word might have different meaning, or they might use a different word to mean the thing that you thought. So there will be multiple domains in any non-trivial system. Each of those domains will have its own language, and in each domain, in each subdomain, it's about learning that language and projecting that language into the code. But more than that, and this is something that happened, I think, circa kind of Rails happening. And this isn't to bash on Rails. The problem Rails had is it was insanely popular, right? Bjorn Straustrup said this about C++. He said there's two kinds of language. There's languages people complain about and languages that no one uses. And in the same way, Rails, suddenly everyone was using Rails because it meant you could write your database code in Ruby, your app in Ruby, your connections in Ruby, your screen in Ruby, and it was a great idea, arguably well executed. But one of the things that Rails did is it gave you the skeleton project, and you spin up Rails, and it will create for you empty folders for for models, views, controllers, helpers, something, and active record definitions and that's models, isn't it? So, but essentially what it was doing is it was imposing the framework structure on your app, and which is a very, very short-term optimization. It saves you minutes of typing, right? What it means is that then when I come along later on to change the payments code is scattered all over the code base because the framework told me to do that. What I want instead is to flip that like 90 degrees. I want to have the solution, the domain space, as my primary structure of code. So I go into my code base, go into my Rails app or my React app or my whatever it is. I go into my code base, and at the top level, I'm seeing payments or loans or onboarding or domain-specific kind of areas of business, if you like, areas of functionality. And within that is all of the code that I need in order to make that code work, in order to solve that particular business problem. So I'll still have all the models using controllers, but they're all together and they're all in the place where I need them. And the third part of domain-based thinking is that we use domain boundaries as module boundaries. So we let the domain need inform the way we're going to structure the code. So that means that our units of deployment, I don't deploy models. I don't deploy, I don't do a controllers update. I push the payments module, right? I push a new version of the payments module with everything it needs in it. And that is independent of the loans module. And this is the kind of core thinking behind good SOA and good microservice architectures and all of those things. And it seems like it's a discipline that we've sort of lost sight of because the frameworks and tools we have try to help us and in fact actively hinder us from structuring things in a domain-oriented way. So that's kind of what I wanted to talk about then. So CUPID, code that has these properties, these characteristics, tends to be more joyful than code that doesn't. Code that has these things more tends to be more joyful than code that doesn't. And again, you can be tactical with this. You don't need to, this isn't all or nothing. You can say, right, let's take a look at the code I'm working with at the moment, or the module I'm working with, the subsystem I'm working with. Which of these, first of all, let's assess our code. How composable do we think the code is, or the pieces in it are? To what extent do they just do one thing, and to what extent do they do it well? How predictable is the code based on what it's called and based on what it looks like it does? How idiomatic did we write this? If someone else came in who just knew this technology but didn't know our company, say, how terrified would they be or delighted would they be with what they saw? And to what extent is the domain, is the solution space represented in the code? To what extent can you look at this code and see that it is pensions administration, see that it is healthcare, see that it is telecoms billing, without needing to know anything else, just looking at the names and the structure and the words? And also, given where I'm at now, and given the problem I'm trying to solve, which of these characteristics would it be most useful to move towards? So let's not boil the ocean. Let's not try and CUPID all the things. Let's decide that this next piece of code, if we can make this next piece of code do one thing, it's trying to do too many things. If we break those out into separate things from a user perspective or from a code that calls it perspective, then that's going to help us reason about it better. It means that when we need to go and change it, then we're going to be more confident about making those changes. Can we make this code more idiomatic? This functional code was clearly written by an OO programmer who was learning FP at the time. Can we go back and make this more idiomatically functional because we're using a functional programming language here and we're trying to make it do OO, and so on. So be opinionated, look at the code you're working with and see which of these properties will help you the most as you move towards it. That's all I had. Thank you very much for listening to me. Do enjoy the rest of the conference. I presume I haven't had Slido open because I know what I'm like and I will be massively distracted by it. So I'm going to ask Jutta if what's been happening over on Slido.
Yeah. So thank you so much, Daniel. It was really a great session, and we do have a lot of questions. Before we go into those, I have two things. First of all, I want to apologize that I pointed everyone to the live transaction subtitles. I confused it. We have this only for regular sessions and not for the keynote. I'm sorry for that. I know it created some confusions at the beginning. And then another thing, just for you, Daniel, to know. So at the beginning, everyone was kind of almost crazy about the PubConf. Everyone wants to go there. And so people figured out where they are happening. And we found out there's no such thing in Germany. So that's about time that we are getting there.
Man, okay. If I give you nothing more than PubConf, this was a success.
See, this is a big success already. Okay, now to the questions. Do you have metrics in mind to measure cupidity? That's a new word, I guess.
That's gorgeous. Right. Okay, I'm going to pop my slides back so we can see Cupid. Do I have metrics in mind to measure cupidity? Honestly, I think the most valuable metric is subjective. It's how much joy do you get from this code. So composability, there's almost a survivor bias kind of thing. Composable code gets reused, so the code that's getting reused by definition was composable, right? So I don't have hard metrics. I mean, certainly with each of these, but again, this is a great question because this is where the nuance comes in, right? For each of these, we could look at this. We could look at, so composability, we could look at discoverability metrics. To what extent are we finding, so if I look across an organization, using things like Simian, looking at code similarity. To what extent is similar code being written in different parts of the organization because they didn't know someone had already done this, right? And so you can look at sort of duplication metrics as a cue to the lack of discoverability. Likewise, I can look at where code is being used and reused in different places, or components are being used and reused in different places, and that should be an indicator as well. Doing one thing well, you can look at look at code that goes around with other code. If I always use these 2 or 3 things together, I have to let my dog out. There we go. Things that don't happen on a stage.
That's true. Which is nice.
Yeah, it is actually pretty one. They are lovely, lovely dogs, but one of them really is very opinionated. So, and like predictability, there's an entire industry around metrics of predictability. So yes, there's functional correctness, but then I can look at all of my operability metrics. So yes, I believe most of these are measurable. I would be really excited to hear from people about how they're measuring these things.
Okay. Thank you. And also on a side note, we will overrun a little bit in order to get to some of the questions at least. So would CUPID be applicable more easily with functional programming rather than with object-oriented programming? And it seems like it.
What I love about this is, and again, this was not intentional, this is an unintended consequence, is that people are seeing what they think of as good code reflected in these properties. So if you're a functional programmer and you take this stuff seriously and you really care about good FP, you're going to see composability, doing one thing well, predictability, all of that stuff. You're going to see that in these. If you're a good dynamic OO programmer, someone who's using, say, a Ruby or a Elixir or something like that, you're going to see these. So these, I believe, and this wasn't deliberate, this sort of just emerged. These feel to me like universal properties. Like whatever your paradigm, any code that is composable is going to generally be more useful than any code that is not composable, whatever your method of composition is, whether that's mix-ins and traits, whether that's class-based composition, whether that's functions and higher order functions. And so whatever your composition mechanics are, if you like, of the technology you're using, more composable is better, right? Mm-hmm. Doing one thing and doing it comprehensively is better. Yeah. So I don't see it as purely FP. What I do see it as, it seems to be attracting people who like enjoying their work, who like having fun at work,
Okay, something along similar lines. Solid is a set of principles for OO design and implementation. Do you see CUPID as a replacement for Solid with the same scopes like OO?
No, absolutely not. So what I see it as an evolution of trying to come up with ways of helping people write better code. Now, if you look at Solid again, and I actually did, I managed to fit this into my 5-minute lightning talk. Is I'm not anti these principles, right? They don't make sense anymore. So for each of them, if you look at single responsibility, so open closed is a great one. Open closed principle says code should be open for extension and closed for modification, right? So that comes from an era when people were thinking that we might sell code libraries, source code libraries. So you'd buy a bunch of C++ classes for healthcare. And so what folks like Bertrand Meyer were saying was, okay, we need to be really opinionated when you get these healthcare classes, that you don't go and break them, right? We want to make the extension points really obvious and the places that you shouldn't touch really obvious. Now that mindset, that's a very sensible 80s, 90s mindset. Then refactoring happened, right? So I should be able to just change code because I want to change code, right? All code is closed, all code is open all the time. And you can, for each of the SOLIND and a bunch of others, you can apply the same kind of thinking. They were really useful guidance for when there are some brilliant anachronisms in English law. I don't know what German law is like, but in English law, for instance, a hackney carriage, so a taxi in London, until relatively recently, had to carry a bale of hay in its boot. The law was that your taxi carriage had to carry a bale of hay. Of course, this is from when hackney carriages were pulled by horses, right? As soon as hackney carriages became cars and became taxis, no one repealed the law. So yeah, carrying hay when you've got horses makes a lot of sense. Carrying hay when you don't have horses just gives you a full boot. And so these solid principles are basically hay in petrol-driven cars. Yeah, they were good advice in their time. Unfortunately, there's an entire industry that's built up around selling training, selling certification, the usual conveyor belt. And so no one's saying, do you think maybe we should let these go now? So that's really what I'm trying to do with CUPID, is to say having guide rails is a great idea. Here are some.
That's excellent. So, and with that, based on seeing that what is the dog's name has now rated the highest,
absolutely.
I think that people are tired, and we finish the Q&A. However, probably we should know what is the dog's name.
I'm sorry they've gone, otherwise I'd have held them up to the camera. So the yappy one is Molly. She's half Shih Tzu and half Maltese Terrier, and she's very opinionated. And the other one, the quiet one, is Chi Chi, and she's pure Shih Tzu, and she just wants to be your friend.
Okay, so we clarified that.
There we go.
Thank you so much, Daniel. That was excellent. Thank you.
Thank you very much. Enjoy the rest of the conference, everyone.